Very good. Should be set to go.
Okay, thank you, Cassidy. Good afternoon. My name is Mazbahul Ahamad, and I'm a postdoc at the University of Nebraska-Lincoln. And today I'm going to talk about a little bit economic of scaling up brush management. So this study is authored by 18 researchers and faculties who are affiliated with University of Nebraska-Lincoln, Nebraska, University of Montana, Texas A&M University, Oklahoma State University, Texas A&M Agri-Life Research and Extension Center. And this research also supported by the National Science Foundation, Nebraska Environmental Trust, USDA, Nebraska Game and Parks Commission. So I want to start off with a little background. As you already know, the Great Plains are experiencing a biome-scale state transition from grassland to woodland due to mainly increasing rate of woody or eastern red cedar or juniper encroachment. As you can see over here, the figure shows the increasing trend of tree cover and decreasing trend of perennial cover in the Great Plains. If you actually, during 1999 to 2018. Over here, you can see the red dots and the tree cover is actually blue dots over here. So it's increasing and decreasing both. So that's actually main concern over here. And that actually declines the forest production and plant and animal biodiversity, groundwater flow and recharge, livestock production and respective revenue flows, especially from both economic and financial standpoint. One of the major concerns is existing brush management relies mostly on reactive or like costly mechanical removal techniques. So more or less like 80 or 70% sometimes. So, and this is one of the most expensive conservation practice in USA. For example, if you consider like the central US and time frame like from 1998 to 2015, the authority spent almost $250 million mostly on this mechanical removal technique just to remove the big trees or big like a juniper trees over here. And the main concern is that actually the increasing woody encroachment still is a concern. It's actually going up and up. So what we need to do actually, we need to scale up brush management. Like for example, right now, it's not actually expected, so we need to actually scale up that one. Just to minimize the woody encroachment and to increase the production and revenue. So this is a two basic standpoint. And by applying appropriate brush management strategies, we have a lot, or at least at 4. So we need to actually either mix and match, or actually we need to find out what would be the most appropriate brush management strategies. So this is very basic concern. So that's actually our research question was, what is the economic cost of scaling up brush management strategies? Like if we want to actually scale up, what would be the cost? So that's why actually we introduce a logic exercise to answer this question. Like for example, I can give you one example. Like if we want to scale up using the mechanical removal, that can cost actually $30 to $200 million for a like a 200,000 hectare area with medium to large size woody plants or woody or juniper trees or any type of the trees. So, and actually that actually brings another question, like policy question. Okay, if we want to do that, so what would be what would be a less costly or more proactive brush management approach? So that's one actually research question, another one is a more policy related question. So to analyze this question and policy question, we actually use a couple of data sets and we estimate a management cost, and we use both primary and secondary data. For the primary data, we actually gathered from 4 different workshops, 3 from Nebraska and 1 from Kansas. And it was actually from, I think it's between 2019 to 2020 in that period. And we also considered the secondary data, like all these published reports and articles published in journal as journal article or reports or something like that. And to calculate the expected management cost, we consider 3 main items. First is management types. So we consider four. One is mechanical, second mulching, third prescribed fire, and four is hand removal. And we also considered the management cost. And over here, we consider two scenarios. One is actually low cost or minimum scenario, like what would be the minimum cost. This is actually average value or something like that, not like very exact. So we try to actually forecast based on this thing. Another one is high cost or the maximum scenario. It may be higher than high cost, but this is, you should consider this is actually very like, average or maiden values actually collected from both like, workshops and the secondary sources. And for the for calculate actually the management cost, we consider actually five different management areas. One is 200 hectare just as a core, and we want to see actually what would be the 200 and what would be the 2,000, 20,000 and 200,000 acre. So we just actually want to see how actually it goes with a low cost and high cost scenario. And expected management cost calculation is very simple. So I just, multiply with management area with cost under actually two different scenarios, like low cost and high cost. So that's our actually data and estimation steps. And here you can see some, the results based on our management approaches and treatment cost. Over here, you can see the management approaches, and on the right side, you can see the treatment cost. So I think you already know the mechanical removal is a very common reactive strategy to actually prevent the woody encroachment, and that use heavy equipment to remove mid-sized to tall, non-sprouting red cedar trees or the other type of woody, encroachment. And this is mostly effective on small areas. Like if it is like a plain, that is more effective, but it is very slopey, or it may be a little bit tough to actually use the mechanical removal technique. And you can see over here that mechanical removal can cost $150 to $1,000 per hectare. So I also want to mention that again, this is actually very maiden value or average value. It may be high or low, because actually we consider the average value, not like the exact numbers. So, and you can see over here the figure, and okay, I'm sorry, yeah. No, and the second one is actually mulching. This is also a reactive management strategy, and that also used to remove small to mid-sized red cedar trees. And that is also actually, good for like the soil erosion, like a concern or something like that, because it may help sometimes soil erosion, especially in the dry season. And that also cost actually, the $10 to $30 per hectare. So that's also an average value. Third one is prescribed fire, and we have a lot of discussion about this thing, and we can use that one also for both reactive and proactive purposes. Like when you actually thinking about reactive, it's probably more or less high intensity prescribed fire, just to use actually, complete removal of like woody, areas or something like that. If it is like very small, like 3 to 5 feet long or less than that. But when you actually consider prescribed fire as a proactive, it may be low intensity prescribed fire used to remove small trees. That's the thing. And it costs actually $5 to $10. Like minimum is $5, maximum may cost actually $10 or something like that. And the last one is hand removal. This is also very proactive, but not very effective for like large areas. This is only very convenient, effective for small acreages, and actually good to remove, the small red cedar or other invasive trees. And this is very cost cheap, like $3 to $5. This is the average cost. So as you can see over here, the figure shows the cover of eastern red cedar on the x-axis and the cost of impact on the y-axis. And we have four different, management, plan. One is prevention, eradication, control, and long-term management. So for the prevention, I think it's more or less the hand removal is best technique, because it costs less money it's cheap, and actually you can do it earlier. So, and if we think eradication or something like that, that type of strategy, I think it's more or less, it cost something like, if you can see over here, it's a mulching, mix of mulching, mix of actually, the hand removal. So that can actually used for the eradication or of woody encroachment. And third one is control. More or less, we can use both fire, prescribed fire, like either like high intensity or low intensity, and we can also use mulching. So either way, actually, that is fine. It depends on the area and time. So this is the control strategy. And for the long-term management, you can see we need to use like both mechanical removal, and we can also use fire too. We can also use mulching. So for the long-term management, it's a little bit complicated because you need to consider a lot of things like the area, density, tree cover, woody cover, and the grass cover, all these stuffs, and the time management, political situation, and everything. The farmers' willingness to actually accept all these stuffs. So it's a little bit complicated than like prevention. So moving on. Oh, okay. So here you can see the cost of scaling up brush management practices, and there are 5 different panels. I already mentioned, actually, we have actually calculated management cost for 20 acres, 200 acres, 2,000 acres, 20,000 acres, and 200,000 acres. As you can see over here, the prescribed fire only cost $100. Maybe it's gonna maximum $200 if you consider 20, and this is the prescribed fire. But if we need to do some hand removal, mulching, and mechanical removal, it can cost much higher than the prescribed fire. For example, if you consider this mechanical removal, it costs like $20,000, like or probably $3,000 just to actually remove, all this like woody encroachment, like especially the mid-size or like the large woody size woods or something like that. And similarly, actually, if you consider the 200 acres, this mechanical removal can cost, actually, it's over here to 20,000, over here is 200,000. So, and if you consider 2,000 hectares, it's gonna cost actually $2 million. But similarly, prescribed fire only 10,000. So that is pretty low, but it depends on the, the tree cover and the density or everything. So, and for similarly, actually, if we want to actually remove woody encroachment or woody cover from large areas, like for example, like 200,000, the mechanical removal can cost 30 million to 200 million. That's huge number. That's the important thing, actually. So we think that actually the cost is not actually a big deal, because every year we actually, cut some woody plants, and we do some prescribed fire and something like that. So that's actually a little bit tough, because every year actually the rate of trees grows is higher than actually what we actually removed. So that's every year actually we accumulated some lands with woody cover that can cost a lot of money in future. So I want to summarize my whole point over here, and we have 2 major concerns. First is the woody encroachment rate has been increasing, which actually the outpacing the rate of land recovered through existing brush management. So that's main concern. So we need to actually do something new, actually how we can actually beat the woody encroachment rate, or at least we can remove the woody cover what we already have or what we gain every year. So that's the main thing. And second one, I already talked about that commonly used reactive or mechanical removal is effective, but it will be economically untenable as the extent of encroachment expands. For example, 20 acres or 200 acres is not a big deal. 2,000 acres probably not a big deal. But if you consider the whole Great Plains or like state, that's a big deal. Actually, we don't have that type of money, that amount of money, and actually it's also cost time. It's time consuming, costly approach. So we need to actually consider how we can actually deal with this issue, because that actually cost a lot of money, especially the beef production and some other forest production and everything. So that's why actually we need a dual strategy that can consider both conservation standpoint and economic standpoint. So I want to emphasize both standpoint because both are important. Because conservation standpoint, that can target earlier stages of encroachment process. For example, like prescribed fire, that can actually target the the small woody stubs. So, and we don't, if we actually burn all these things, so we don't need to actually employ the mechanical removal. So that can actually save some money. Or we can actually do some hand removal. But okay, for if you consider the big area or Great Plains, it's not actually feasible. We cannot actually cut all these things down. So we also need to economic standpoint, because okay, someone can say, okay, this prescribed fire has a lot of things and negative externalities like carbon footprints and smokes and biodiversity, everything. But we also need to actually consider the economic standpoint. What would be the impact on Nebraska, or what would be the impact of on the Great Plains in terms of like the beef production and all these things. So that's why actually we need to employ and consider both economically superior approaches compared to the mechanical removal. Okay, mechanical removal is not a bad one, but we need to think about this when and how actually we can remove the woody plant. So there are some other things over here, because not all these areas are what is called are like same. Like some actually maybe 200 acres like one grassland have like 50% of like woody encroachment, and some actually percent like 20% has probably perennial and some other stuffs. So yeah, so that's actually we need to consider both of these things. So both conservation and economic standpoint. So that's why actually based on this logic exercise, I think this is very simple, but this is actually very important too, because of the Great Plains and the grassland and the like backward and forward linkages of this rangeland and grassland in Nebraska and like neighboring states is very important. So that's actually, I think our recommendation is we need to move forward more preventive control strategies for scaling up brush management. So it's a little bit confusing, but you can define how we can define the preventive control strategies. So which one is actually most or appropriate or something. So I can say that actually it's a little bit confusing or little bit actually area dependent. I think the NRCS or the authority, they can actually consider what would be the next most appropriate, the control strategy or something. So, and the second one is that we need to analyze how to proactively manage the sources of woody encroachment to prevent future costly rangeland restoration across the Great Plains. So that's also a little bit critical, because we need to forecast both the woody encroachment, considering the small trees, mid-sized trees, and like large tree. So we need to actually find out actually what area are more, dense with like woody encroachment, woody plants, like large woody plants or medium woody plants, and we need to find out the the sequence and when and how we can actually remove all these trees, and what would be the best strategy to employ all these things. So we can use both mechanical, we can use like prescribed fire or mulching or probably hand removal. So it's a little bit complex. So we need to do a lot of things to actually find out more proactive. Like, okay, and over here we need to also consider that what the amount of money we need to actually do this thing, and what would be the projected time frame. Like we need to plan next 5 years what we can do, next 10 years what we can do, or something like that. So I think this is a little bit I think we over here want to actually present a little bit logic exercise, just to actually raise the question, what would be the most economic economically superior approach considering this rate taken by woody covers, and actually we reduces by the mechanical or any other type of treatments. So I think that's all from my side, and if you have any question, I'll be happy to answer this. Yeah.
Mazbah, thank you so much. I'm going to go ahead and stop recording.